The coronavirus from Wuhan, China continues to spread across the globe. Many more are becoming infected and some even dying. As of making this video, 132 people have died worldwide, with over 6,000 infected in China alone. But what actually happens to your body if you contract the coronavirus? Now, before we get into it, we want to make clear that this video is in no way intended to spread fear or over-sensationalize the severity of the coronavirus. We won't be commenting on its global threat level because that information is constantly changing while experts monitor its spread.
But what we will be looking at is how the coronavirus actually infects the body, what it does inside of you, and then how it causes symptoms, spreads, how your body actually then fights it off, or it causes death in some. Coronaviridae are actually an entire family of viruses that cause disease in mammals and birds. SARS, for example, was also a coronavirus. Now, viruses are interesting in that they are sometimes considered both living and non-living things. They aren't made of cells, but they do have the ability to replicate, just in a different way than other organisms. Oh, and they're actually much smaller than cells.
Now, to contract the coronavirus, you first have to come in contact with it, either through an infected person's respiratory secretion, so a cough or a sneeze, through physical contact with them, or by physically touching a surface that the virus is on, and then touching somewhere like your nose or your mouth before washing your hands. Once the virus is able to enter your body, its work can begin. One thing that all viruses have in common is that they carry some kind of genetic material, either DNA or RNA. In the case of coronavirus, it carries RNA, which has all the information the virus needs to replicate. The genetic information in a virus is typically surrounded by a protective capsid.
You may picture this when you think of a virus, and it is a virus, but this is a virus that attacks bacteria, also known as a bacteriophage. In the case of the coronavirus, the RNA is encased in a helical capsid, and then that helical capsid is actually encased in an envelope. It looks more like this, kind of like the emoji of a virus. And these projections coming out of the surface, or the club-like structures, are very important for what happens next. Once the virus comes in contact with your cells, it binds to receptors on that cell. You can think of the outer layer of the virus like a key. And if the virus has found the right cells in the right species, its keys are able to open the lock on these cells. As a result, the virus is able to enter, where it now has access to all the cell's machinery.
Now, normally this machinery is reserved for your own DNA, which uses something called ribosomes to make proteins that have all sorts of functions and travel all over your body. But the coronavirus ends up hijacking this system. It uses its own RNA to go to those ribosomes and starts making proteins that it wants. So basically your cell starts producing viruses by making the genetic material, by making the capsid and envelope, and ultimately your cell becomes a virus-making machine. And this is why viruses are often considered non-living, because they don't actually have the machinery to do this work. They actually need your body's cells to do it. So the coronavirus has its RNA instructions read over and over and over and makes protein after protein after protein, and ultimately can make millions of viruses. These viruses eventually fill the cell and make their way back to the cell membrane, where they break out, often destroying the cell in the process. Once out, it's on to the next cell to repeat the cycle all over again.
Now, as your cells begin to get damaged and die, your body will sense this and start to trigger an immune response. And both of these things are what will create these symptoms that you begin to feel. In the case of the coronavirus, these symptoms include headaches, runny nose, coughing, sore throat, and fever, which is part of the reason why it's been so hard to track and understand, because those are common symptoms. We feel those all the time, especially during flu season or just from getting the common cold. Medical professionals would need to do laboratory tests on respiratory specimens, as well as blood work and blood tests to understand if your symptoms are coming from the Wuhan coronavirus.
In a healthy individual, the immune system will eventually realize that there's a foreign agent inside your body and mount an attack. The immune system is incredibly complex, with a plethora of different mechanisms to take down your invaders. Your temperature increases, which helps your immune system function better and actually makes it a more hostile environment for the virus. You might create more snot and phlegm, which make it harder for the virus to attach to your cells and also help to get rid of dead viruses and immune cells. You may feel weak and tired as your body starts to prioritize fighting off this virus instead of doing your regular day-to-day activities, and your bones may actually feel sore and ache, and that's because they're actually making more white blood cells. For its mainline defense, when the coronavirus is detected, the body triggers signals to start producing antibodies. These antibodies are created by your own DNA. There are essentially sections of code in each cell's DNA that contain the instructions of how to build different defense systems. Enzymes in the nucleus find the right section of DNA, make a copy called messenger RNA, which gets sent to the ribosome in your cells, which will read these instructions and start making the relevant proteins. With up to 10 million ribosomes in each cell, they become an antibody-making factory, which are sent outside of the cell to fight the virus.
The trickiest part for your body is that the immune response doesn't catch the virus right away, so essentially, the virus starts with an upper hand. This is why it can take so long for your body to fight off a virus. But for coronavirus, those with healthy immune systems should be able to fight off and rid the body of the virus within weeks. The problem is primarily for those who have compromised immune systems, which is often people who are elderly or people who are very young. This particular coronavirus has mostly affected the elderly, and that's because as we age, our immune systems become less effective and they actually slow down. As the virus continues to proliferate and cells continue to die, in a desperate attempt to save your body, your immune system can go into overdrive. In severe cases, white blood cells are responsible for activating a variety of chemicals, which can cause the leaking of fluid into your lungs. And this combination of cellular destruction from the virus and fluid-filled lungs interrupts the transportation of oxygen into the bloodstream, which can lead to suffocation and organ failure. But the virus isn't always the cause of death. Often, with a weakened and distracted immune system, other organisms like bacteria are able to take advantage of the body, causing further complications. As organs begin to shut down, the whole body can as well.
To reiterate, it's the immunocompromised that are most at risk, and even with that, it's worth saying that the numbers are relatively low. If you think about it, 40,000 people died of the flu in the US alone last year, and over 1 million people died of heart disease. On top of that, the death rate right now is being estimated between 2 and 3%, which is continually evolving, but a disease like SARS was a death rate of 10%, and Ebola in some regions has been up to 50%. All this to say, don't allow the news to make you panic.
We live in Toronto, where the SARS virus got world-scale attention. That's because the only people who died outside of Asia from that virus were in Canada, and most of them were in Toronto. With only 44 people dying in total in Canada, it had a huge impact on our city. We lost a lot of tourism, we lost millions of dollars, but most importantly, we saw a lot of stigma and racism towards Chinese people. It's important that we do not repeat those racist notions that happened here in Toronto, and we all need to be aware of this when we talk about the current coronavirus. On our social media channels, we have seen lots of people saying things like, "This always happens in China," and relating it a lot to the types of foods that Chinese people eat. But it's important to remember that Western food practices are what created mad cow disease, and also Western meat consumption has created a big issue with antibiotic resistance. We need to listen to and trust public health professionals, and we need to not overreact, and we need to not use this as an excuse to be racist. If you like these videos, make sure that you have subscribed. But Mitch, we have some news.
Yes, we have also started a little mailing email list with the link below because, you know, sometimes you subscribe, people say they don't always see our videos pop up. So we want to make sure you're getting them. So
the YouTube algorithm is confusing,
yes,
to say the least.
We are here to subvert the YouTube algorithm. So if you want to help our channel, make sure you just get notified when a video comes out. It'll just shoot you over an email and let you know.
We'll be emailing you.
Sign up below. Otherwise, we'll see you next time for another science video.
Peace.
See ya.
The coronavirus. It's spread beyond China.
We have confirmed the first case of Wuhan novel coronavirus patient in Singapore.
Cases have been confirmed across Asia, in the US, and today in France. It's not been designated a pandemic, and it's uncertain whether it has the potential to become one. Yet health experts stress that the scale of the pandemic threat is potentially catastrophic.
It has not yet become a global health emergency. It may yet become one.
A new strain of disease develops. Few, if any, people have immunity. Airborne human-to-human infection enables rapid progress through a population. Globalized travel and urban living puts rocket boosters under its spread. So how well prepared is the world to cope with a pandemic?
Well, epidemics such as this are controlled by standard procedures, which include identification and isolation of those who are infected and sick. The second is to trace all of their contacts. And then the third is to make sure that other means of control can be employed. And sometimes that includes requiring people not to travel or asking them to postpone travel.
This is the latest invention in the fight against SARS.
Scares over SARS in 2003, bird flu in 2006 and swine flu in 2009, and also Ebola and Zika in recent years, have focused policymakers' minds on the need for pandemic preparation. The World Health Organization has established a global influenza surveillance network covering 105 countries as a planetary alert mechanism. But it's one thing knowing what the right procedures are, it's another thing ensuring that they are carried out. Last year, a group called the Global Preparedness Monitoring Board, convened by the WHO and the World Bank, warned of major gaps in our pandemic preparedness. It cited a lack of long-term, holistic, costed resource mobilisation plans. It said that not a single country's preparedness plan had been fully funded. Further, it warned that the WHO itself was underfunded, hindering its ability to provide a global safety net.
There's clearly a gap in funding, and the funding for developing capacity to detect and respond to outbreaks is not being funded by national governments in many developing countries, nor is there complementary funding coming in from development agencies. The World Health Organization is always underfunded. Their budget is very little compared to the responsibilities that they have.
Some experts stress that when it comes to protecting ourselves from pandemics, there's a danger in placing all our focus on short-term emergency responses.
You also need in the long run a sustained focus on building and strengthening healthcare systems at the national level everywhere, but obviously particularly in countries that don't have strong healthcare systems at the moment. So for an international response to be able to effectively support in a crisis situation, you need people on the ground who are well trained to support this response, to know what to do in an emergency situation. But you also need a population who trusts the local health systems, who will actually listen to crisis communications. They will go and seek help in healthcare facilities.
So is our planet prepared for a pandemic? To answer confidently in the affirmative, we may also need to see this hyper-connected world of ours become considerably more equal in terms of access to decent, basic healthcare.
Dr. Tom Inglesby is the director of the Centre for Health Security of the Johns Hopkins Bloomberg School of Public Health. He's an expert in how viruses spread. And Sarah Gilbert is Professor of Vaccinology at Oxford University. And Dr. Inglesby, if we start with you, I understand that you and your team conducted a simulation of a global pandemic of a type of coronavirus and came up with a figure that it could kill 65 million people. I wondered how you reached that figure.
Yes, a few months ago, we put on an exercise in New York City that used a fictional coronavirus and watched it spread over a period of 18 months. And the exercise took place early on in the pandemic, so much earlier than what we might fear later. And we basically studied past coronavirus outbreaks, other pandemics, to try and understand that and try and understand what might happen if a pandemic really played out at a global scale.
I mean, it's interesting because, of course, in reality, we haven't seen anything like that, nothing on that scale, 65 million deaths. I mean, it's hugely high. We do get warnings of these pandemics every few years, but we haven't seen that kind of numbers. Is that down to luck? Are our systems working, or are the models wrong?
No, well, I think if you go back in time, we did see back in 1918, in the last big pandemic influenza, we saw somewhere between 50 and 100 million deaths. Things have gotten a lot better since that time. We have much more modern science and medicine, but we're also much more connected and in some ways more vulnerable. So I think we see a lot of trends that worry us, like the globalization, the movement of people around the world, living closer with animals, antibiotic resistance, megacities. So there are a lot of trends that worry us. We hopefully will never see a day when we have the kind of pandemic we saw in our exercise. But the reason we held that exercise is because we think it's scientifically feasible that something like that could emerge, and we need to prepare for it as a global community.
Professor Gilbert, we hear about vaccines taking a long time and always being sort of lagging behind whatever it is that they're trying to vaccinate against. I mean, are things changing? Is the technology coming down the way that will mean that's different this time and in future?
Yes, things are changing, but it's definitely still a work in progress. So in the past, vaccines were often developed from the disease-causing organisms themselves, and they had to be isolated and then adapted and then tested, and vaccine development would take a long time. Now what we're looking at is new ways of making vaccines, using technology that we can adapt for each individual situation to make a vaccine against a different disease. And because we've used the technology before and we know a lot about it, it enables us to go faster in the vaccine production and the testing and eventually the implementation as well. But it's still not going to be immediate. It's still going to take us several months before we have a vaccine that's ready to go into the first clinical trials. And after that, we have to test if the vaccine not only induces a strong immune response against the pathogen, but if it's actually strong enough to protect. And that testing will take longer, and then production of enough doses of vaccine to vaccinate enough people to control the outbreak will take longer again. So we're probably still, in the best case scenario, looking at about a year before we've got enough doses to make a real impact.
And that's what I was going to ask. I mean, do we have the means to manufacture a vaccine on a kind of pandemic scale?
Well, it depends how many doses we're going to need. If the contact tracing and quarantine and the public health measures are very effective at bringing the outbreak under control, that can dramatically reduce the number of cases. And that's how Ebola outbreaks have been dealt with up until now, when we didn't have a vaccine. But then towards the end of the outbreak, what would tend to happen is that small clusters of cases will keep arising. And if we have a vaccine available at that time, that's very useful for controlling the cases at the end of the outbreak. And it doesn't take very many thousands of doses to achieve that. On the other hand, if we're going to need to vaccinate hundreds, thousands, millions of people, we don't have manufacturing facilities in the UK, certainly, that we can use to make that number of doses. We would need to collaborate internationally to achieve that scale of manufacture.
Dr. Inglesby, in the situation we are in right now, in the situation that China finds itself in, what do you think is the best public health approach? Is it share the message quickly and risk panic, or is it deal with it in a more low-key way but risk spread?
Yeah, I think in all cases, the public should be getting all the information that the government has. I think once the public senses that information is being held back, that's when people start losing confidence in a response, confidence in the government that they need to trust to get through this. So I think we need to really give as much information out as possible to the public and to international partners who are also planning their own efforts to try and prevent disease spread in different countries. So I think we should share information. We should work very hard to identify cases with diagnostic testing, isolate people who are sick. I'm worried about larger scale quarantine efforts. Quarantining large cities like this have not happened before in modern times. So I'm worried that's going to get in the way of doing other things that we need to do.
And like what? What other things need doing?
Like finding the patients, getting them to volunteer and come in for testing, and getting them to be isolated in their own homes, or if they're sick enough, isolated in hospital, getting medical care for people who are sick, bringing healthcare workers to the places where people are sick. All that requires movement of people, movement of goods, movement of hospital supplies, and big quarantines can interrupt the movement of those things and also make people afraid.
And Professor Gilbert, I mean, in the UK, there's a lot of unfounded skepticism about vaccines, and I wonder whether that impedes on the work people like you are doing.
I don't think so, really. Once people see a need for a vaccine, once they see a disease that is causing illness and causing deaths, most people are really very interested in receiving the vaccine.
And clinical trials take a long time, and the end process is human testing. Does that process fit in with these new viruses?
It's difficult to do clinical trials when an outbreak's actually happening. But what we do need to do, first of all, is test the vaccines to see if we're getting a good immune response to the vaccine, how many doses of the vaccine we need to give, and the technology that we're working with in Oxford and with our spin-out company Vaccitech works very well after a single dose of vaccine, which is important in an outbreak. We then have to try and judge whether we think that would protect people against infection, and then design trials that will actually test if the vaccine is working. We don't want to just go and vaccinate large numbers of people with a vaccine when we don't know if it actually works or not. So designing the trials to get that information while the outbreak's happening is very difficult to do.
Professor Gilbert, Dr. Inglesby, thank you so much for joining us.